Hello again. In this section, we'll start by describing systems and their behaviors. In order to describe a thermodynamic system, we will use properties. In properties such as for example, mass, pressure, and temperature. Mainly, we can know the condition of the system if we know the value of its properties. So, it's important in thermodynamics to know the value of the properties of the system. So when the value of the properties change, we can say that the system or the condition of the system has changed. So a quantity is a property. So we'll now define what is a property. A quantity is a property if and only if its change in value is independent of the process where that change happened. So, for example, the weather temperature. So let's say today is the weather temperature is 20 degrees C, and tomorrow it will be 23 degrees C. So the change in temperature between tomorrow and today is delta temperature between tomorrow and today is 3 degrees Celsius. So I don't care what happened between today and tomorrow. So at night, maybe the temperature went down to 19 degrees, 13 degrees, but tomorrow the value is 23 and today is 22 degrees. So the change in temperature is 3 degrees. So it did not depend on the path from today to tomorrow. So for these reasons, we can say that the temperature is a property. Another example will be for example, the volume. The volume is a property. Suppose we have a piston cylinder. So this is the piston and this is the cylinder, and the volume initially inside was 3 meter cube. So after some expansion, due to some reason, the volume become 5 meter cube. So the change in volume is 2 meter cube. I did not care how the volume changed from 3 to 5 meter cube, but the change in volume is just the value of the final state minus the value of the initial state, which is 5 minus 3. So during the process, what happened to the volume did not influence the change of the volume from the final state to the initial state. So that's why we consider the volume is a property. We have two types of properties. Two types. Intensive and extensive. So an intensive property, so for a property to be intensive, if it is for intensive, if its value is independent of the size of the system. Independent of the size of the system. An extensive property is a property whose value depends dependent on the size or extent of the system. So, for example, let's look at some properties and classify each one to be intensive or extensive. I will teach you like a simple test to know if a property is intensive or extensive. Let's say we have some block, and what we do is we cut the block in half. If the value of the property inside the block is also divided by 2, that means this property will be extensive. If the value after cutting is still the same, that means that the property is intensive. For example, let's say we have inside this block a mass of 4 kilograms. So if we cut the block in half, here we will have 2 kilos, and at the left we will have 2 kilos. So the mass is extensive. Another example, let's say we have volume. A cube has a volume of 4 liters. So if we cut the cube in half, the volume will be to the left 2 liters and to the right 2 liters. So the volume is extensive. Let's take, for example, the temperature. So here, let's say a cube which has an inside temperature of 20 degrees C. If we cut the cube in half, we will have to the left 20 degrees C and to the right 20 degrees C. Since the value of 20 degrees C is not summation of all the values in the cube, so the temperature is intensive. Another example, the pressure. So if you take a room, for example, that has inside a temperature of 1 bar, if I cut the room in half, I also will have 1 bar here and 1 bar to the right. So the pressure is an intensive property. Another example, let's say the density. So if we have a tank filled with water, and you know the water density is approximately 1000 kilogram per meter cube. If I cut the cube into half, the water will still have to the left a density of 1000 and to the right a density of 1000. So the density is an intensive property. Okay? So now we'll move on to specific properties. So in thermodynamics, whenever we hear the word specific, it means per unit mass. So when I say specific volume, and is denoted by a small v, is the volume divided by mass, and it will be in units in meter cube per kilogram. So if we can also relate the specific volume in thermo to the density, which is the specific volume is the inverse to the density, as we all know that the density is the mass over volume. So the specific volume is also an intensive property, just the same as the density, an intensive property. And if you can notice that the volumes, the specific volume is the volume over mass. Here the volume is extensive and the mass is extensive. But the ratio of two extensive properties give an intensive property. So you can say that the ratio of extensive properties is intensive. Another property is in thermodynamics is the specific energy. Small e is capital letter E divided by mass. So specific energy is the total energy per unit mass, and has the unit of kilojoule per kilogram. So now we will move to the definition of a state. So now we'll talk about state. The word state in thermodynamics refers to the condition of a system described by its properties. So it is the condition of a system described by its properties. So whenever the property of system change, we can say that its state change also. So if we have some property, any property change, you can say that the state also change. the word steady state refers that there is no more variation of properties with respect to time. So, like for example, if we have like a hot cup of coffee at, for example, T is equal to 35 degrees Celsius, and the ambient temperature is 20 degrees Celsius. So finally, if we leave the coffee cup for some duration, it will reach the same surrounding temperature. So it will be at T. So finally, it will be at T equal 20 degrees Celsius. So in this process, because the hot coffee will lose heat to the surrounding, because there is some temperature difference from the hot body to the cold body. We lose heat. So at the end of the process, the coffee cup will reach the same surrounding temperature, which is 20 degrees C. So here we say that the coffee cup undergoes some state change. So its state has changed from T or from T1 to T2. And because the property has changed from 35 degrees to 20 degrees. And at the end, when the T no longer changes with respect to time, we can say that we have reached steady state. So no matter how much long we leave the cup of coffee, it will remain at the same temperature of 20 degrees as the surrounding. So the property temperature no longer changes with respect to time. So we say that the coffee has reached steady state. Okay. Another thing we need to know is to define process. The process in thermodynamic is a transformation from state to another. Like if you want to know or to see this graphically, let's say in the y-axis we have some property, we call it property A, and in the x-axis we have some property and we call it property B. And a system is at state 1, like let's say this point here, we say the system is at state 1, which is defined by a value of two properties B1 and A1. So we say here that the system is at a state defined by the properties A1 and B1. So whenever one of these properties change, we say that the system has changed its state from state 1 to state 2. So here, let's say the system undergoes some change due to some interaction with the surrounding and has reached state 2, which is defined by the properties A2 and B2. So here we are at state 2. So the transformation from one state to another is called a process. So the process is a transformation from state 1 defined by the two properties A1 and B1 to state 2 defined by other two properties or by the same properties but with different values A2 and B2. Okay? For example, another example, if we take like a piston cylinder assembly, and here there is air, for example. Air has some pressure P1 and a volume V1, and the air undergoes some compression process where the volume will decrease to V2 and the pressure will increase to P2. So if we draw this on a PV diagram, it's called a PV diagram, where the pressure is in the y-axis and the volume is in the x-axis. So here, the x-axis we have the volume and in the y-axis we have the pressure. Initially the volume was high, so this is V1, and the pressure was low, P1, and the compression process has increased the pressure to P2 while decreasing the volume. So the volume has decreased while the pressure has increased. So we have a smaller volume V2 and a higher pressure P2. So the system has changed its state from 1 to 2 by undergoing a compression process. Where the properties has changed from V1 and P1 defined by state 1 to P2 and V2 defined by the state 2. Let's take some further examples to processes and how we can interpret processes. So, interpreting processes. If we draw this is PV, let's say 1. So we have some change from 1 to 2. What we can say about this process? This is a constant pressure process where we have a volume decrease. So the volume decreases in this process. Another process on a PV diagram, pressure volume diagram, let's say the process is like this, has some vertical process. So this is a constant volume process, where the pressure P increases. Another example is, for example, we have state 1 here and state 2. In this process, the pressure decreases while the volume increases. So, like an expansion process. An expansion where the pressure decreases and the volume increases. Now we'll move to the definition of a cycle, a thermodynamic cycle. A thermodynamic cycle is a sequence of processes, where the final state is the same as the initial state. So where the final state is the same as the initial state. For example, this is the PV diagram. This is the state 1, the initial state, and the system undergoes like several processes. For example, 1 to 2, some expansion, some further expansion to 3, and a compression to 4, and some further compression to 4. So to 1, sorry. So what happened here is we started at state 1, and we finished at state 1. So state 1 is the initial and final state, is the same. So we can say that the system undergoes a cycle. So whenever you see like some closed area, you can say that the system undergoes a thermodynamic cycle. So here we have a closed area bounded by all the processes 1 to 2 to 3, 3, 4, and 4, 1. Okay. So other types or special types of processes has some terminology in thermodynamics, and we need to identify what these terminologies mean. So now we'll move to constant property processes. So if we say an isothermal process, it means constant or the same. So iso, same or constant. Thermal is referred to the temperature. So it is a process where the temperature is constant, is held constant during the process. Another type of processes is called isobaric process. Isobaric process. An isobaric, it means a process where pressure P is constant during the process. Another type is called isochoric or isometric process. So in this process, the volume V is constant during the process. For example, if you're drawing a temperature with respect to volume diagram, TV diagram, to see what the first isothermal process means, we draw TV diagram. It is a process where the temperature doesn't change during this process. So this is an isothermal process. For the two left examples, we talk about a PV diagram. An isobaric process, this is P and this is V. An isobaric process is also a process where the pressure is held constant. And for isochoric or isometric, the process is a vertical process from 1 to 2. So this is isochoric process. Or even on a TV diagram, isochoric will be something like this. 1 to 2. Also, we can say this is an isochoric process. Okay. In the next videos, we will talk about mass, length, time, force, temperature, and pressure, energy, and specific volume, and molar or specific molar volume, and we will discuss the units in two systems, in the international system SI system and in the inch pound system. To see you in the next video.